Let's use the method just illustrated to solve the car passing two posts problem. So step one was to sketch the situation. That's writing down what we know. So here was what my picture will look like. I'm going to draw a line with a start and an end point. I will choose an axis pointing to the right. It doesn't matter which way you choose it. It makes the most sense this way since the car is going from start to end to the right. But you must choose an axis. Then I will start drawing certain information on the picture based on what was given in the problem. So I was told between start and end, the car displaced 40 meters. I was also told how fast it was moving at the first post, 50 miles per hour, and I'm looking for how fast it's moving at the second. This is a very simple picture illustrating a few things. I tend on motion problems to only draw things at the start, at the end, and what is between them, meaning velocities and displacement. Everything else will appear in my list. So let's start making a list of what we know, where some of this comes from our drawing. So, delta x, 40 meters. So you need to know the symbol that displacement represents. We were given the time 1.59 seconds, and we were given v0. I know this is v0 because this is the velocity given by the units, and it's at the earlier time as 50 miles per hour. This does need to be converted to meters per second, so there is a conversion in the front of the book that converts between miles per hour and meters per second under the speed area. And that conversion is this: 1 meter per second, 2.237 miles per hour. And watch as they cancel out, and we end up with 22.4 meters per second. What we are looking for is the final velocity. So these are the terms that I was given and the thing I was looking for. And here are the other two terms. I tend to draw a dotted line and say here are the other quantities. So I always have all 6 quantities listed. So now this is writing down what we know. Now we need to pick equations. The way I tend to solve these is to look for one equation that can give me the answer. In this problem, there is not. I simply can't pick one equation that has these quantities that will give me an answer. So what that means is I may have to solve for one of the other terms and substitute in. I can, in this case, find v bar by using this equation. Delta x equals v bar t. So v bar is delta x over t, which is 40 meters over 1.59 seconds, which gives me 25.2 meters per second. So now I can consider that known. This now helps me find the final velocity by using this equation. V bar equals 1/2 v plus v0. This can now be solved for v, so you do need to know your algebra to solve these things. Solving it, v equals 2v bar minus v0. And we have all that information. Here's v bar, here's v0. And when you put the numbers in, you end up at the final velocity of 28.0 meters per second. And now we can do a very quick check. The first check, the car is still moving to the right. We called positive to the right. We got a positive velocity. So the velocity, since it's positive, points this way, which makes sense. The number seems reasonable given all the other numbers.